Hi everyone, I'm Joe Pasquale. This is my submission for the Human Factors and AI course project on Coursera. Guidelines of this project is to design the user experience for a product with focus on key AI specific considerations of inputs and outputs, transparency, uncertainty and feedback loops, and then evaluate privacy and ethical considerations. So to do that, we're going to look at a task analysis, user experience design, privacy considerations, and some ethical considerations. So before we jump in, let's look at the problem and solution. This is from a previous project. The head of acquisition operations at Company X has overpaid on 50% of homes. This company buys single-family homes, rents them out to families after renovation. And they're overpaying because they're getting their repair estimates wrong. Why this matters is, well, they're losing money on real estate deals, they're not able to grow, they're risking layoffs, and rent increases is bad for the company's reputation. Current state, company just uses a heuristic average repair value as its estimate, and our model intends to predict a more accurate estimate repair value through an ensemble model of classification of photos from the inspection and the inspection checklist, a price book data, accounts payable data. That goes into the model, which then goes into the broker's UI. So when that broker then speaks to the seller, they have a more accurate revised bid and hopefully negates overpaying on the home. The process is triggered via the broker app and the broker when an initial bid is accepted on the home. That triggers an inspection that's ordered, and the inspector then arrives at the home. Right here, I'm thinking there might be some representational biases, and we might be always choosing a certain inspector. There could be historical bias if this home is in a new market, so we've got to be careful there. Then there's a decision, which is the output of an inspection. It's the checklist that's performed. We could get measurement bias here and compliance, law, risk, if we don't standardize that checklist. Photos are taken of the problem areas. Again, we might have some measurement bias here if each inspector is using a different app or a different camera, or the quality of the image is not consistent. We need that in our model to be consistent. Then the inspector submits the final inspection. That data is then ingested into the machine learning model. The machine learning model calculates estimated repair value, stored, and then sent to the broker's UI. When that value is updated, and then that broker has the decision on whether they want to keep on negotiating with the seller with a revised bid. Again, we might have some bias here in the model in terms of learning bias of the model. How is it performing over time? So we need to make sure we're monitoring our output metrics. And deployment bias, again, we want to make sure that we're deploying this to all brokers, not just a subsection of them. So let's look at the user design for the Inspector app. For any application, we should follow principles of interactive design. Visibility, feedback, constraints, mapping, consistency and affordance, and also some AI considerations as well. In general, this is a field app, so it needs to be on an iPad or an iPhone, should be easy to use. The role of the inspector here is really as data collector, so we should weight the data points important to our model first. There should be a completeness tracker, so the inspector knows when they're finished and they've got everything that we need for the model. There shouldn't be any ambiguities. If we can, let's use a checklist format with drop-down values. The inspection should be sectioned up into rooms and location, and the whole experience should be easy to use, right? So from an AI perspective, the inspector doesn't really need to know anything about the model, its outputs, because it should really be independent of knowing those things. Really, we should focus on the user inputs. So again, we want a nice, clean, consistent data structure that's provided via this app. We need some scoring guidelines maybe where some of the inspection items are a little bit more subjective, and we need a photo feature on the app so every inspector is using the same application to capture severity of repairs. The other app in the workflow is the broker app. This is the consumer of the model, so I'm going to focus more on the AI considerations here. Firstly, the user inputs. Good idea always for consumers to see the inspection in this case, to understand the data that was collected. They can have that conversation with the seller. Transparency into the model, yes, absolutely. The broker as the consumer needs confidence in its accuracy, as well as the documentation on how it works and who that model owner is, so they can ask some questions. Communicating uncertainty. The model should show a probabilistic range of estimated repairs rather than deterministic. This is going to be a better fit for when it comes to negotiating a deal with the seller, to have a minimum and maximum range. And in a feedback loop, I think this is advisable to have an explicit feedback loop on model bias and variance. This should probably be performed by an independent asset manager, and a good example here is they're looking at the repair values, they're challenging the inspection, they speak to the inspector, they look at those repairs, and maybe, there's, because of budgetary concerns, there might be a recomputation of repairs, and we can present that to the broker. Privacy considerations. The model should be compliant with Fair Information Practices, FIPS. Also, home inspectors are required to follow the Privacy Act of 1974. This act governs how federal agencies can collect and use data about individuals in its system of records. Also, we've got to think about the variability of laws within different states. For example, California has the California Consumer Privacy Act, CCPA, which gives California residents the right to know what personal information is being collected. Other states like New York have very similar laws. Other data privacy laws such as FCRA, GLBA and GDPR are not applicable to this model. And finally, to conclude, let's think about ethical design and risk mitigation. All models need to be fair, accountable and transparent. So when we apply it to this use case, our definition of fairness is that every home is valued consistently, primarily based on geographic market and condition of the home, and it's not influenced at all by demographics of the owner. How do we stay accountable? We need to have strong governance and clear ownership over the performance, monitoring and iterations of these models and their outputs. And transparency, well, we need to be transparent to all users in how this model works, how it arrives at its results, and the level of confidence that we have. We also ensure that this model is only used within the application and workflow it is intended for. And then let's think about biases, so how we control risk going forward. Best way to do this is set up strong governance. So example is an executive leadership weekly forum on model results. And the things that we're looking for here are biases on historical basis, representational bias, measurement bias, learning bias. So examples in this use case are for historical bias that the models are retrained automatically when we enter a new market. The markets that we had when we originally trained this model might not apply to going into a new market such as New York or Las Vegas. A representational bias, I think we need to be aware that accuracy of estimated repairs is really reliant on the inspector, and as individuals there could be a lot of variability over time, so that needs to be monitored. Measurement bias, again, we can mitigate this through standardizing data collection in the inspector app, and we weigh the objective deterministic data over the more subjective things that are being captured in that inspection. We can also ensure that all photos are captured using the same resolution from the same app. Again, we need that consistency because it's important for the severity classification part of the model. And then learning bias, I mean, we should always continue to monitor this performance at a regional level and make sure we're not smoothing things out on an aggregate national level. So continual monitoring and mitigation of bias through accountability, transparency, and governance. Thank you for listening to this, and thank you so much. Bye-bye.